Good morning, everybody. Thank you for coming. It's always a worry of mine that I'm going to end up talking to an empty room, so it's good to see there's a few people here. So, what am I going to talk about? So, as you probably guessed from the title, I'll be talking about some microservices stuff. So, first of all, who am I? I'm James. I've been working at ThoughtWorks for about the last 3 years now. Before that, I worked at a startup for 9 years. And the startup, what I've done at ThoughtWorks, so this is kind of an experience report of all of that. What's good about microservices, but mainly actually what might not work. So a little bit about ThoughtWorks. I have to put this slide in for marketing purposes. I'm not going to dwell on that. So before I crack on, I'd just like to say something about what I've noticed about being in this conference. Lovely place, Vienna. Architecture. I noticed these buildings. I think that's actually this building, the one on the right. I love the way that those bridges reflect in the one side of it. It looks like the bridge has got an angle in it, whereas in fact it obviously hasn't. I saw this talk yesterday about quantum computing, which I found absolutely fascinating. I've got to say I don't really understand it all, but this slide looks fantastic, so I thought I'd take a picture of it. And of course, he spoke about Schrodinger's cat, which I think I sort of understand. So I drew an analogy about Schrodinger's cat. This is actually not Schrodinger's cat. This is my daughter's cat. So this is Clementine's cat. And as you can see from the picture, it's displaying one of the typical cat emotions, which is utter indifference. A while ago, I asked my daughter, I told her about Schrodinger's cat, and I said, what do you think of this? And she was horrified that anybody would put a cat in a box and gas it or whatever. So I asked her to think about that, and she said, okay, so Clementine, if you say all these things to the cat, try 8 different things, as many different things as you can, and what you end up with is something that looks like this. You see, the cat can display lots of different emotions. So that's Clementine's cat. Apologies for that. That's nothing to do with microservices. So, onto the stuff that I am here to talk about. So, a little bit about the key benefits of microservices. I want to talk about complexity and how we reason with complexity, what it does in your application. A bit about outcomes, and then that's really the meat of the talk, is how you get to the outcomes without necessarily going the full microservices way. And I'm going to talk a bit about some of the case studies, some of the stuff I've actually worked on. So, first of all, why do we do microservices? What's the point of them? Well, you can see loads of talks online about microservices. I think everybody's seen Martin Fowler's talks. There's a guy that currently works for ThoughtWorks in the UK called James Lewis, and he has a great talk on Conway's Law and how to get that working in your favor. So, what are microservices? What do they do for you? So I think the first thing up there is reducing handovers, reducing communication taxes between teams. People familiar with Conway's Law? Yeah, 1 or 2 people. So what Conway's Law states, it was put together sometime in the 60s. It basically says that the software systems that you build within an organization will mirror the communication patterns of the organization itself. So if you have various teams, they will build their own bits of software, and the way that the software communicates will mirror those real communications. Communications are expensive. We have something that I talk about, which is communication tax. It's very costly. So I think that's probably one of the most important outcomes. Then we have all these other things that people like to talk about, independent scalability of components, which can be important. A massive thing is independent code bases so that you can do your own releases. You should reduce complexity in components. Technology diversity. I've heard this trumpeted as a good thing. I'm not all that convinced, to be honest, but on the project that I'm working on currently, we have Java microservices. We also have Clojure microservices. So in theory, you can use the right tool for the right job. System downtime. Yeah, there are ways using microservices that you can degrade your service better so that the UX is more consistent. The whole thing doesn't need to go down as it would in the old days of monoliths. And the last thing I've added there, platform thinking. When I was working in a bank for ThoughtWorks, they had this notion that they wanted us to create a platform for loans. So the way to do that, well, one of the tools for doing that was to use microservices so that they could be used by different parts of the bank. You know, the bit that did various capabilities like checking your creditworthiness, things like that. So I want to talk about complexity briefly. I actually saw a slide that looked a bit like this in a talk at Berlin last year. So if you have a system that has 5 things in it, and if they can all talk to one another, this is kind of modeling some sort of monolithic system, you're going to get up to 10 possible connections there. If you add one more thing to your system, and I'm deliberately calling these things rather than modules or anything, just to keep it abstract. If you add one more thing, that's going to add 5 more connections. So you're up to, what, 15 connections now? N things, this is a simple mathematical formula, will have that many possible connections. So, for example, the possible complexity of something with 16 things in it is 120 connections. I haven't drawn the picture because it would look ridiculous. So, how can I reduce the complexity? So, here's a system with 16 possible things in it, and as I say, there's 120 possible connections there. But what if I group them into related things like that? And if I then say, call these contexts, if I only allow connections between the contexts or between the things in the same context, I've now reduced the overall complexity of the system. So now in this example here, there's only 31 possible connections. So have I reduced it? Have I made it easier? I'm not so sure. I've seen people argue that that's a way of simplifying the system, and in some ways it might be. In the interest of political balance, I've got Obama as well. The thing is, have you really made the thing simpler? In reality, would you connect all 16 things to every other thing? Probably not. There can, in the model on the previous page, you might have multiple connections between your different contexts. So it's not just one connection. There could be various different messaging systems going on. There could be all sorts of other complexity. And I think one thing that people don't really consider is you've introduced other complexity. And that complexity can be harder to reason with. It's pretty easy to follow the code flow in a monolithic app. You can debug it. You can just step through the code. You can see what it's doing. It's pretty obvious. It just said, do this, then do this, then do this. On the other hand, if you've got a microservices system that's sending RabbitMQ messages and it's sending HTTP requests everywhere, it can be hard to trace the request through the system. You end up using things like what's it called? Kibana to trace a request. There's a Kibana plugin that we use that follows the Rabbit messages, and we got it to draw this diagram, and it looked so ridiculously complex it was untrue. So here's a quote. I'll let people read that. You may have read that somewhere, but it's doubtful because it's my quote. And I think one thing that we need to realize is that microservices, they won't make your system simpler. They will move the complexity around. And I think it's very, very important that we understand that and we say, okay, where's my complexity gone? Because it's still there, and unfortunately I think it can be different complexity and it can be harder to reason with, as I say. We've got things like deployments, many, many different builds, all sorts of things like that to consider now, and lots of different technologies. So, what am I saying on this slide? Sorry, first time I've given this talk. I don't know whether it flows properly yet. So, yes, right at the top there, we're saying your microservices, the components should be small enough to reason with. According to my colleague James Lewis, they should be small enough to fit inside James Lewis's head. I don't know if that's a universally accepted definition. James is quite a clever bloke, so that means massive as far as I know. But so the individual components are probably going to be easy to reason with, but the overall system might be difficult to reason with. I think it's key to understand this. Orchestration between components is clearly necessary. How you do that, I shouldn't have used the word orchestration there because that has a precise definition, but getting them to do stuff is harder than it used to be. Tests. Wow, the burden of tests on your system is now massive. You have to consider all the integration tests, all the things like availability tests and things. We've got monitors on POM monitors on my project looking at the whole system. You've got more builds. I think the last count on my project, we've got something like 150 different pipelines in our build system. And technology diversity, I think sometimes people say it's a good thing, but also it can be a bad thing. We've got dozens of different technologies in play, Ansible, Chef, CloudFormation, all these different things for provisioning, and various bits of, as I say, Java, Clojure. There's obviously front-end stuff written in JavaScript. So it's really hard, I think, for any individual to get that overall picture of the system. And monitoring and maintenance, you've imposed that overhead on you. So, rather than talking about microservices as a thing, what I've seen happen is we've gone in as ThoughtWorks on some engagements and the client says to us, we want to do microservices. So they sort of view that as an outcome in and of itself. And I don't think that's necessarily valuable because it's a solution to a problem. It's one solution to a specific problem. It's not in and of itself an outcome. So I think a good way to approach things is to say, well, what outcomes are actually important to us? So as I briefly mentioned earlier, communication tax, handovers. We often do an exercise in ThoughtWorks where we map out a path to production and we stick stickies on the board and say, these are all the handovers. This is where things are hard. So why are handovers important? What's the problem? Well, I like using an analogy for this. If you imagine this person has to give that piece of paper to the other person, so she needs to hand over the piece of paper. If the paper gets wet, it's going to lose fidelity, or the message will get blurred somehow. So in this first picture, this is modeling them being in the same team. They're literally in the same boat. It should be pretty easy for her to hand the piece of paper to the other person. Now, if we look at this, these people are not in the same team, but they're both in a boat. They have empathy with one another. They have sympathy with one another, sorry. So this could be a team, two teams that are aligned to the same goal. So maybe it's a database team and a development team. One has to hand over to them. It's going to be slightly more difficult to execute that handover. It might take a little bit longer. But if the first handover takes minutes or hours, the second handover could be days or weeks. And then the third type of handover you get in organizations, and we see this a lot in banks, is what we call a transactional handover. Now, in this picture, she needs to give the paper to this person in the submarine. Not only does she have to wait for the submarine to surface, she has to somehow communicate to the submarine to surface. She has to know when it's going to surface. She has to know where it's going to surface. It's really hard. So that's a transactional handover. And they've got no sympathy, no empathy with one another. Frankly, they don't care. So if you can reduce handovers, it's a good outcome. Another good outcome to head for is do your own releases. It shouldn't be possible in this day and age. One team should not be able to block another team's release. Simple as that. So that's a very valuable outcome. I mean, one of the biggest dysfunctions we find as ThoughtWorks, we go into a new client and they tell us, yeah, it takes us months and months to do releases. And typically it's because there's this whole massive orchestration of releases going on between teams and they have to do it in lockstep. And the first thing we'll try and do is unpick all of that, reduce the dependencies so that each team can release its own code. What am I saying there? Oh yeah, coordination overhead. And it's important to think about when you do releases, it doesn't necessarily have to be onto separate servers. I've worked on a successful implementation of microservices where they didn't have their own separate servers, so it's arguable if that's a real microservices thing. Independent scalability of components, that's a good outcome to head for. The service that receives requests directly from the website probably has different scalability requirements from the one that takes orders. The one that checks stock will probably, again, have different scalability requirements. It's important to realize, though, if you are going to be interested in scaling your individual components, you are, again, introducing a big management cost to it. I think I touched on, I was speaking to a chap yesterday after one of the talks where one thing that I haven't come across yet is useful abstractions for hardware. And I think we might be getting there with tools like Kubernetes and things like that. But it annoys me that in this day and age, even when you're using something like AWS, you still have to think in terms of servers, you have to think about NAT gateways, you have to think about firewalls, all that stuff. There's no useful abstraction which just says, hey, here's an app, deploy it. And that sort of annoys me. I know there are things like Heroku and so on, but I'm told that's not an enterprise solution, but yeah, that's my whinge for the day. Strong module boundaries. This is something the tech principal on my current project likes to talk about. Strong module boundaries are good because they help keep context together. They make it easier to reason with what's going on. Microservices will be decoupled from one another by definition, although sometimes they're sort of coupled in ways that are insidious. And again, I've mentioned Conway's law there. You should use microservices in a way to get Conway's law working for you. Get the people that work on the same stuff working together. Excuse me. It is true to say that in a monolithic application, you can have good modular structure. It's just it might be more difficult to enforce. People will end up making references from one bit to another and so on. So it's not as easy to enforce your modular boundaries. Okay, let's talk about some trade-offs. What are the downsides? So Martin Fowler has an excellent talk, which I've linked to there, called Microservices Premium, where he talks about, these are the things you've got to do. You need to consider automated deployment. If you don't have automated deployments, CI/CD, I don't think your microservices implementation can work. You need monitoring. You need stuff like Kibana. You need a good logging monitoring system. You probably want alerts going out. We've got, as I say, a massive build monitor that goes red whenever the network goes down, things like that. You need to understand how to deal with failure. It's not good enough to just let the system fail. Bits of your system will go down, so you need to know how to isolate parts of the system. You need to start considering things like the circuit breaker pattern and so on. Oh, eventual consistency. I saw a talk about Kafka earlier today, and there was talk of the databases and how you need to move data from one part to another. It's a massive overhead. We've got so much code in our project that just makes sure that the picture of the data is consistent. Big cost. I think I called out developer complexity as something that's a cost as well, because as I say, I think the developers, or certainly the leads, the people that sort of span the whole project, need to know so many different technologies. And then the service-to-service communication, that's a cost. You need to understand the protocols. You need to be consistent with your patterns, and this whole sort of maintenance cost is ongoing. And then I've noted down certificates, firewalls, all the things. That's the stuff that I don't understand. all the security things. So that's the microservices premium. And when things go wrong, they can go badly wrong, and I've seen them go badly wrong. Sometimes I've worked on a microservices project, but even though the elements are not tightly coupled, they're still coupled in sort of hidden ways, and people have to coordinate their releases still. So I like to say to them, how come your story is releasing 4 services? That shouldn't be like that. Maybe the stories are written wrong. Maybe we've implemented it badly at times. I don't know. It's possible in your microservices implementation that you might solve the same problem over and over again. Arguably, there's less reuse of code because you're no longer got the option to reference libraries. Here's an important point as well, which I've noticed in places where I've worked. The funding model can lead to big dysfunction. If you have things like banks are fond of doing, where they say, here's £1 million, go and build this system. and they expect you 6 months later to have finished with it and hand it over to a support team. That is a very dysfunctional model, and you know, I think you need strong product-based ownership of the thing, otherwise it does decay over time. I think that's the same point on the next line, actually. Should probably combine those two bullets. And the final point I'm making there is, and I've seen this happen, again, James Lewis, I mentioned him earlier, he's got a phrase which is, if you go into an organization and you can reorganize it and you can just create new silos in different places, and James likes to call that, okay, we went in there, so-and-so, and the organization is now differently broken. So that can happen if you're not careful. So, now, here's some case studies. Now, these are real things. I've changed some of the details, I've paraphrased a bit, but this is stuff that I've worked on in the last sort of 5 or 6 years. So, here's a problem statement. This was in a startup that I worked at for 9 years. We had a whole big monolithic application, and like a lot of these things, it had evolved over time. It got harder and harder to do stuff. We had a team that was responsible for the public-facing website. We had a team, which actually I was running, which was in charge of the sort of internal tools space. We had other teams, and the whole thing had a single SQL Server database. And it was hard to do stuff. And I think crucially in the microservices discussion, we didn't have it in the cloud yet. This was 5, 6 years ago, I guess, when this story starts, probably around about, God, I'm getting old actually, it's probably more like 7 or 8 years ago. So, to sort of illustrate, this is what the solution looked like. But of course, that's much simplified. Wow, that's massive. But you can't consider this on the left without also considering what teams went alongside it. So we had those 4 technical teams there. And they're sort of loosely arranged on sort of horizontal layers. The web team were mainly front-end people. The tools team that I was with was sort of, we're in charge of those SOAP services and the internal apps. We had an infrastructure team, we had a database team. But also, you have to consider the business teams. And there was at least 5 of them. There were probably others. As I say, I'm simplifying somewhat. But the crucial thing about this is, what do these teams care about? So if we look at the web team, they sort of care about most of the web app and part of the database. Tools team, which I was involved in, we cared about that stuff. Infrastructure team, well, they cared about pretty much everything. And then the database team, well, they cared about the database, obviously. They were doing things like optimizations and so on. But they also had a sort of stake in the stuff that talks to the database. They were always making sure that we didn't, kill the database with terrible stored procedures and so on. So that picture's starting to look a bit confusing, but I'm about to make it more confusing, because the sales team cared about that stuff. The partners team probably cared about those bits. You can see where this is going. And the other teams cared about those bits. So now we've got a really confusing picture. And we would find that if the sales team came to us and said, oh, we want to do something, we want to change this bit of the website to help with our search engine optimization, it was hard to do. We had to make sure that releases were coordinated. We had to make sure that the one team didn't break the other team. Usually the web front-end team sort of won out, and I got annoyed because they would release stuff and break the tools, and then I'd get the blame. So what did we do? So our biggest problem was not treading on each other's toes. What we wanted to be able to do was release stuff. So we identified, we said, that's the outcome we want. To be honest, back in those days, I don't think I'd even heard the word microservices. But we started to move it to something which did look a bit like microservices. We refactored the monolith. That was our first step. It was move it into bounded context, is what I'd call them now. Back then, we probably called them modules. We started using shared assemblies. We started pulling stuff out into NuGet packages for things like security and cross-cutting concerns and database access, things like that. Essentially, we split the code base vertically so that it more accurately mirrored the business. So we were effectively, I didn't know the phrase at the time, but we were doing what James Lewis calls a reverse Conway maneuver, where we sort of shifted the business to fit the software and logically arrange it. And we made our teams cross-functional. We added front-end people together with back-end people and database people. So we brought it all together so that each team could be responsible for the whole development cycle. We didn't do anything to the database. We kept it as a monolithic database. So crucially, I think if you see microservices, true microservices implementation, every service will have its own data store. So we didn't touch the database effectively. And we didn't do anything with the infrastructure. The infrastructure basically stayed in a data center. So this confusing picture became this. So as you can see, what we did to effectively, to get the outcome we wanted was as I say, that is what we call the reverse Conway maneuver. We arranged the teams with the software people, and we actually distributed the software team throughout the building. There used to be an area for tech and the area of the business people, but we actually spread us out so that we were sitting with the business that we were part of. But the database team stayed on its own down the bottom. They were special. So, what was the outcome there? What did we achieve? We achieved separation of code bases. That was the biggest thing we wanted, so that we could do independent releases. And we got a closer alignment between business units and the teams delivering value to them. That is a very ThoughtWorks-y statement. That's me adding my own narrative now. I didn't quite understand how important that was at the time. We didn't achieve separate scalability of components. Whether or not they've done that now, I don't know. I haven't seen anybody from that company for a while. We didn't achieve bounded data context. And that was something that actually annoyed me, because I had this argument with the database team where I was constantly saying, we have this view of a ticket, and we've got this database table, and it's got like 200 columns in it. But each part of the system only addresses a small subset of those columns. So I was constantly arguing, we have different views of tickets, so why don't we have different tables? So it annoyed me that we didn't have bounded data context. Oh, I didn't win that argument. We avoided having to manage eventual consistency, crucially, and that's maybe why we didn't split the database up. And we didn't introduce extra developer complexity. In fact, arguably, we made it a lot simpler because we were able to concentrate each team on just the bit that they cared about. So, now's a good outcome. Or, as Clementine's cat would say, she's totally not bothered. Here's another quick case study. This was something I worked on with ThoughtWorks recently. We were in a publishing company. They asked us to work on this UK application, which was new. They already had a US market application. They were trying to use that as a kind of framework. And the scary part was it was taking them 13 plus months to get something from the ideation stage into production. That was their big problem. They asked us to come in and say, okay, how can we reduce this cycle time? And we at ThoughtWorks, we said, okay, give us 12 weeks and we'll prove that we can deliver value quickly. So what did we do? We found that the biggest problem was silos in this business. This is a slide that I've changed the names on, which actually, we use this in a presentation at the client. This is my colleague, Karen. She wanted to do something that was effectively quite simple. It felt like it should take just a couple of days at most to achieve this outcome she wanted. So she spoke to some people in the business, which involved a few phone calls, a few emails, and she spoke to various teams. That told her about a system that she needed to access to get value from the system, which then introduced another person that she had to talk to. This used to have actual names on it. It doesn't now, which is sad. That person told us about another person who we had to email because this person was in a different time zone, so we couldn't just pick up the phone and talk to her. And then, amazingly, we found out about another system that we didn't even know about. It was like, oh God, so that system controls that system, so we need to talk to that system. Gosh, this is getting confusing. Then that introduced another person with lots more emails. All of this is taking a stupid amount of time. Finally, they told us about the real team that we needed to talk to. And eventually, we got hold of the right people, we found some documentation, we managed to do it. This simple outcome that should have taken like a day or two, it ended up taking Karen 3 weeks to even understand what the start of the solution was. And the problem there was silos. Every single person on this slide represents a person or a team. They're real people, they have real jobs within this organization, but they're in technology silos. Each of the people here understands exactly what their piece of software does to the content, but they have no idea how that affects the functionality in the application. So we realized that, so here's a little schematic. What this company did essentially was it takes raw documents. They can be news articles, they can be published legal stuff, and it does stuff to the documents so that, and it gets put into a document database. And then, oh yeah, I forgot about that. This is, they call that content production. And each of those has various silos. I think we counted 15 different silos in those yellow boxes on the left there. And that's basically to get a document, which is a raw document, and put it into a sort of XML format such that the application can read it and it enhances it and it gives it functionality. Then on the application side, there was something called shared display services. There was this US application, there was this UK application that we were building. And they called that application teams. Now, the amazing thing about this was the UK app was so tightly coupled to those shared display services, which in turn was so tightly coupled to the US app, that in order for us to release the UK app into a pre-production environment, bear in mind the UK app wasn't live yet, the US app was. When we wanted to make changes to the UK app, we had to deploy the US app at the same time. That's how tightly coupled they were. And the company thought that this stuff happening on the left could happen entirely dependently of the stuff on the right. They had this project plan that said, on this date, all the content will be ready and the app will be ready, and they were just expecting it to magically work together. It wasn't going to do that. So what did we do? We realized that what they were lacking was an understanding of product thinking. So initially, when we were doing our analysis, we were going up to people and we were saying, okay, what does your system do? And then we realized that was the wrong question to ask. What we should have been saying was, why does it do it? What functionality does it enable in the end user app? And by doing that, owning the whole outcome, we were able to effectively bust the silos and just bypass all those silos and just pick out the functionality we wanted. And we were able to, does this slide have something else? Oh yeah. So we built our own little piece and we hived it off. We built our application for our functionality. We deployed it separately, and it was basically the main UK app was reverse proxying onto it. The company called it a microservice. It wasn't really a microservice. It didn't have its own data store, but it was separately deployable. And crucially, we reduced the cycle time from 13 months to a matter of days. We were rolling out features, you know, from the point of starting a story to getting it into the pre-production environment was taking us like a couple of days. So that was a great outcome. So what did we achieve there? Shorter cycle times, that was the biggest thing, because we didn't need to traverse the silos. We made Conway's Law work in our favor. We owned the whole outcome. And we got separate scalability because we deployed our thing to our own servers in AWS, so it could be scaled on its own separately from the main UK app. And another thing we achieved was we changed the way that company thought internally. We got them customer focused. We got them to start understanding what customer focus meant. It was a great journey for us, actually. It taught me a lot about what customer focus means and how it's really valuable in delivering decent software. However, we had to manage our stuff now. We had to do our own deployments. We had to learn Terraform. We had to understand all that stuff. As I mentioned earlier, it annoyed me that I still had to reason in terms of servers, firewalls, and so on. And we didn't reuse code. The client was a little bit uncomfortable with that because we actually solved some same problems that were already solved. But in the end, it was like, well, you know, we're getting things done much quicker. And we imposed this overhead of monitoring and support. So it had good and bad outcomes. Or as the cat says, still not bothered. So, I'm going to finish with top 5 tips on microservices. Tip number 5, this is a countdown, sorry. You can start with a monolith. If you're going to do that, great. I would always say if you're doing a brand new project, it has to get to a certain size before microservices start paying off. So, there's no reason not to start with a monolith. If you design it well, you'll be in a good place to split it up later. Tip number 4, you need to understand the cost. It will cost extra stuff. It will cost in complexity. It will cost in real money. It will cost in all sorts of ways. And I've just called out some of the things. I think I mentioned most of that earlier. I noticed that picture there that I got off Google. Somebody had that in their presentation earlier today. Same picture. You need strong technical leadership. This is something that I've noticed on the current implementation I'm working on. You can sort of see over time how the client has asked us, at times, has asked ThoughtWorks to not be there, and they've taken ownership, and then they asked us to come back and retake ownership because they were finding it hard to manage themselves. And you can kind of see the different philosophies that have been in play, and it makes it very confusing. So you need that strong technical leadership. You need a good tech vision, and you need to be, somebody needs to be curating that and making sure all the dev teams stick to it. Understand your outcomes. I think the biggest thing on this slide is that first bullet point. Ask yourself, okay, if microservices are the answer, what was the question? What are we trying to solve here? What's the problem we're trying to solve? Understand those outcomes and go for them. Understand what good looks like. And finally, if you do it well, you will get great outcomes. This is Martin Fowler's phrase, you must be this tall to use microservices. I recommend reading that blog if you haven't done. As long as you understand what you're getting, you will get a great outcome. And that's all I have. And here's some book recommendations. Thank you for listening. I think we've got a couple of minutes if anybody wants to ask any questions. No? Everybody dying for lunch now? Okay. Thank you very much, everybody. Thank you for coming.